All right, this is page 1 of the second integral summary packet. So we're going way back to 1995 for this one. I would like to note, though, we can go all the way back to 1995 because all of the questions are sort of run along the same general theme over the years. So, calculus is calculus. Okay. This says the graph of a differentiable function f on the closed interval is shown above. So this is not f prime, this is f. Let h of x equal the integral from 1 to x of f of t dt from 1 to 7. So what does that mean? So h of x is the accumulated area between 1 and however far we want to go. All right, so find h of 1. So what is h of 1 going to equal? So just go with the definition here. That means that if I plug in 1 for x, I'm doing the integral from 1 to 1 of f of t dt. And the integral from 1 to 1 should just be 0. That was easy. Okay. What about h prime of 4? So before you plug in 4 here, figure out, well, no, I guess you could do 4 at the same time. So if I take the derivative of the integral, so I could do this. I could say, let's do h prime of x before we plug in 4. That's equal to the derivative of the integral. So remember, when you take the derivative with respect to x of an integral, what are you going to be left with here? So okay, so the derivative and the integral cancel out, yes. But remember, whatever the variable is here, the reason they have this as f of t dt is because this variable gets inserted in. So f of x. If that said x squared, it'd be f of x squared. And then you multiply by the derivative of that upper bound. The derivative of the upper bound is 1. And there's no plus c here because this is a definite integral. We're just using x as the upper bound. Okay, so that means that h prime of x is equal to f of x. I did not have to show that for the AP test. I could jump right to h prime of 4 is equal to f of 4. You do have to show something. Either h prime of x equals f or h prime of 4 equals f of 4. You have to show something there. And then you get your answer. So what is f of 4? So f of 4 is 2. So h prime of 4 is 2. Okay, what about part C? On what interval or intervals is the graph of h concave up? How do I know if a graph is concave up? So I can think of two things. Concave up when h double prime is greater than 0, or concave up when h prime is increasing. I can use either one of those two things as my justification, but I need to relate h double prime or h prime back to the f graph. So remember, we just said h prime of x is equal to f of x, right? So h of x is concave up. I know we abbreviate CCU, but write the words for the AP test. So h of x is concave up when h prime of x equals f of x is increasing. Okay, when does that happen? So let's take a look at f's graph. F is increasing from 1 to 3, and then it increases again from 6 to 7. So this occurs on the interval 1 to 3. I'm not going to include my endpoints because I said increasing, and I'm not considering endpoints to be increasing. And then 6 to 7. You could have also said, I'm going to give you the or here, h double prime of x is equal to f prime of x. So I could have said h of x is concave up when h double prime of x, which is f prime of x, is greater than 0. And you're still looking on f's graph. Translate that to f's graph. Greater than 0 is still when f is increasing, right? So that's why I didn't really go that route, but you could say that. Okay, what about part D? Find the value of x at which h has its minimum on the closed interval 1 to 7. Justify your answer. So we're going to use extreme value theorem for this one. And this is where we write out the candidates. Remember, the candidates are the endpoints or any place where we have a relative minimum. So start with the candidates. We're talking about h of x. So the candidates are the endpoints. I always start there so I don't forget about them. And then do we have any place where h has a relative minimum? So h will have a relative minimum. So let's see. H will have a relative minimum when h prime changes from negative to positive. So when h prime, which remember that's f of x, changes negative to positive. You don't need this for your AP answer. This is more for me to keep it straight in my brain. So I'm looking at f of x. Does f of x ever change from negative to positive? No, it changes from positive to negative, but that would be h prime going up and then down. So there are no relative minimum points. So the only candidates here are at 1 to 7. Okay, and then remember, you need to still calculate h of x. So it's a good idea to set up the work for this. So h of 1 we already found. If you want to show it again, that was the integral from 1 to 1 of f of t dt. So that was 0. And then what's the integral from 1 to 7 of f of t dt? So the integral from 1 to 7. Now, I can't find the actual number here, but what do I know about it? There's this big positive area, and there's this small negative area, so it's definitely net positive. So I just know that this is greater than 0 because the positive area between x equals what? 1 to 5? 1 and x equals 5 is larger than the negative. Maybe I could get away with saying because the net area is positive, that's fine. But I'm just going to explain this. Is larger than the negative area between x equals 6 and 7. All right, so what was the question? Did I actually find it? Find the value of x. So x equals 7. Is my final answer. X equals 7 is where the minimum is. All right, that finishes this video. We'll do another video for the second page.